This is Advent of Code 2020, Day 3, Toboggan Trajectory. And in this puzzle, we've got a narrow but really tall map, which we're going to have to traverse in our toboggan. And we traverse the map moving 3 to the right and down 1 each time. And so the goal of this puzzle is to figure out all the spots we're going to sort of land on, I guess, and to determine whether we run into a tree or not. And ultimately, we want to output how many trees we encounter. So like I said, we move to the right 3 and down 1 for each sort of movement. That's how our toboggan traverses across the map. You see, this map is quite a bit longer than what we saw above. We also notice that it looks repetitive, and that's because as we sort of traverse along and get to the edge here, we'll just repeat the entire portion of the map. So this whole thing will kind of, you can imagine us just like copying, pasting it here and here and here and here, all the way across, and we'll just keep moving along sort of the repeat of that map until we get to the bottom edge of it. So that's sort of our end case. When we reach the bottom edge, then we count up all the trees we've hit, and that number will be our solution. So let's take a look at the puzzle input. Here we go. It's a pretty big file, pretty tall thing. A lot to deal with. So we will make a directory and jump in there. And because we have so much input, I'd actually like to start with just like an input file. And so we'll create a constant called input. And I'll put myself in paste mode, and I'm just going to paste all that in like that. And similar to other days, I'm going to do a block selection. I'm going to give myself 2 spaces and a string. So I want to create some valid Ruby syntax here. We'll do another block quote, and we'll jump to the end of the lines. We'll do a Shift A, close the string, put a comma, and now we have an array of all of our input. So I'm going to quit out of that, and now we'll open up, I guess, part1.ruby, and we'll do a require relative of, call that input, I believe. Yeah, we called that input. Okay. So we'll do require relative. And now we should have input available to us. And so I think we're going to have like a parse step again. So we're going to have to parse the input map into, some sort of array of data that we can work with. And then we'll have a step where we actually, I guess, step through the map, traverse the map. And look for trees. And then just to give ourselves something to work with, let's, something to look at rather. I'm going to copy and paste that over here. So paste again. So yeah, we'll start at the topmost corner, and we're going to be dealing with movement of 3 to the right and down, down 1, 3 to the right, down 1, 3 to the right, down 1. Then when we hit here, that's 1. We'll go 2, 3, and then down 1. So actually now as I walk through that, I'm kind of thinking I might be able to I'm thinking that because of the sort of flexibility we have with array access in Ruby, we might not have to overcomplicate this problem. So let's open up ERB and think this through for a second. So yeah, if I had, an array of data like this, so if I say, data 0, I get the first thing. If I say, how many do I have? 1, 2, data size. Okay. So if I say data 7, that's going to be past the bounds of the list. So that's nil. Okay. But can I wrap? If I do like input modulo data.size. Yeah, maybe something like that. So whatever position I want to access, I can just sort of keep monotonically increasing it. And then modulo with the size of the array to sort of make it wrap around. So it's 7. Data.size is 0, right? So that would then give us the 0th position, which is what we would have wanted. Okay. So yeah, let's try something like that. Well, I guess I'm getting ahead of myself, but let's maybe document that. Some position of interest modulo row.size, I guess. So we'll use that to access the position we're interested in. But first, yeah, let's figure out how to parse this thing. Parse input. And yeah, do we want to pass? Yeah, maybe just like one row at a time. So if we just pass one of these, geez, I don't even know if we need to split out a method here. I think we can just say like input.map, and then for each one of those, we can split it. Oh, split might do a space by default. Let's see. All right, so we got to give it an argument of that if we want to split it out. Okay. That's fine. So we'll just map over the line, and we'll call line.split. Split it an empty string. And yeah, that'll be our array. So that'll be, I guess, our map. Maybe map's not a terrain. Sure, we'll go with that. Great, so now that we have our terrain, we're just going to be moving, yeah, over 3 and down 1. So it's just, yeah, a matter of like checking our current position, then moving to the next row, checking our position on that row, moving to the next row. Yeah, I guess we just want to like iterate over every item in this terrain because we're just moving down one at a time until we get to the very end of it. Okay, and then ultimately we want tree count. So we will say terrain dot dot filter, I guess. Just going to find the ones that intersect with trees, and then we'll count that list. So we'll say tree.filter, call it a row. So our first row is just a miss because we're going to go over 3 and down 1. So we don't even have, we start okay in the first row. And I think if we let it input, we'll see, yeah, that's the case. Oh, so, yeah, do we train dot with index dot filter? Is that a thing? Oops. Do we have an example using this? Oh, so we need an enumerator first. So each with index filter. Maybe that's what we can do. Each with index filter. And then, yeah, the index is just a second argument. So we'll say if, actually no, we don't need to overcomplicate this. Sorry about that. Our first position is going to be the 0th position. So we're just going to be maintaining sort of a, I guess, is this our x-axis? Or is our y-axis? What are the, yeah, this is our x-axis. So we're going to be maintaining a count of like the x-axis position. So we'll say x equals 0. And then as we go, we'll say, yeah, encountered tree gets row x. And I'll say x plus equals 3. Oh, and this is where this comes in. Modulo row.size. Okay. Counter tree. So then we'll return the result, and so that's where our filter will add up. So we'll find, basically we'll get each result that gets included in the filter will be a row that encountered a tree. We don't really care about that data, so maybe filter is not the best construct for this, but we'll just do a count at the end. We'll ditch our tree count, and we'll just say rows tree collection dot count size. And I think that might be a solution. Let's I guess give that a run and see if it works. Let's see, Ruby part 1. 323. Does that seem plausible? If we jump back to here, how many? I don't know about that. Oh, whoops. Need to actually check if we encountered a tree. And let's run that again. 51. That seems like a more reasonable number. Should we see if 51 was the answer we needed? Down here, plug in our answer, 51. And that is not the right answer. Bummer. Okay, so let's go back to the drawing board. Make sure I read the problem correctly. Yeah, that's a miss. That's a hit because it's a tree. All right, am I looking at this right? 1, 2, 3, 3 down 1, 1, 2, 3 down 1. That's a hit. X where there was a tree. Yeah, 1, 2, 3, 4, 5, 6, 7. Okay. So is it possible that the counting is off? Yeah, we start at the 0th position. Get rid of that index now. I don't think that's gonna... Oh, that did make a difference. Whoops. Kind of like that being a higher number. 51 did seem kind of small for 300 and some rows. Well, let's give that a try then. So 193. There we go. It's a little stray syntax once we removed that with index. It's tripping us up, but we got our gold star for the day. Thanks for watching. Maybe in another video we'll look at part 2.